Welcome to the project demonstration of Regenerative Braking System along with boost converter. So the main application of this project is in heavy vehicles we are going to drive the wheel with the help of a DC motor, and whenever we apply the brake the so-called power will be lost. So in order to regenerate the power from the generator motor when we apply the brake, so the system will use this the help of this DC motor, which will act as a DC generator also whenever we apply the brake on this DC motor. So here we are using a 1000 rpm DC motor. The ratings are like gear ratio is 2004. This one is the 24,000 rpm motor, so the gear ratio will be stepped down to 1000 rpm, and again it will be step up to the 1:2 ratio. So there is a gear ratio will be increased over here in order to provide the torque when we are rotating this, when we disconnect the power supply to this motor. Means, so when we apply the power supply to this DC motor, then it will act as a motor to convert the electrical signal to the mechanical energy, and then the mechanical energy will be converted to this wheel. So when we disconnect the power supply to this DC motor, then this will act as a flywheel. Then the power will be revert back to this motor in the same gear ratio, and then it will act as a generator. Means the mechanical energy will be converted into the electrical energy, and that will be given as input to this boost converter, and from there we are going to charge a battery. We are using a lithium ion battery pack, so which has a 3.7 volts battery pack. The output of this boost converter will be given to this battery pack through this charging circuits, and continuously we are going to monitor the battery voltage as well as the boost converter voltage which is coming out from this DC generator. The two voltages will be displayed on the LCD screen. The measuring of this voltage will be done through this PIC 16F72 microcontroller. So this is a transformer to provide the power supply to charge a battery through the charging circuit, again same way. And the next is, this is a power supply adapter for the microcontroller. So let us see demonstration. Before demonstration, so connect this positive at this positive side of this motor, and the negative should be negative side. So while connecting, check properly, this should not be attached to the each side. Then after, this is the on off switch to make a DC motor as a DC motor, and when you off that, the DC motor will act as a generator, means mechanical energy to the electrical energy. So the next step is, before demonstration, keep the battery under full charge, and now on the power supply to this motherboard. To charging of the battery, we can connect this cable to the 12 slots. There we can see the light indication, so which will show the battery will be charging, and on the LCD we can see the voltage of the battery pack and the next voltage from the generator. So let us see that. Then we can see the LED indication also whenever the DC motor acts as a generator. So now the DC motor, and when we on this, you can see the light indication on this generator slot also. So we can see the same thing on the LCD also. Resetting this. So generator, it has a boost converter as a capacitor. That's why it is discharging. Now you can see this. The generator voltage is 17 point. So around voltage will be generated from this circuit.